Okay, so in this one, we are going to talk about complex conjugates, which is a concept that we're going to need in order to be able to do division, because it's the only operation that we didn't talk about in the previous video. So the first thing is, again, these are dashes on this PowerPoint. They are not negatives, okay? So a complex conjugate, if you have A plus BI, then the conjugate is A minus BI. And similarly, if you have the minus plus. Now, I'm going to put a list of these over here on the board. And so that you can see kind of what we're talking about here, so that you can visually kind of see what's happening here. So I'm going to get these over here. So let's say I have 3 plus 2i. Then the conjugate of that is 3 minus 2i. If I had negative 7 plus half I, this is negative 7 minus half I. If I had 3 minus 4i, then it's 3 plus 4i. And then if I had square root of 5, sorry, negative square root of 5 minus 0.6i, then I would have negative square root of 5 plus 0.6i. The thing to note here is the only thing that is changing is this sign in the middle, okay? Notice here that the negative 7 still stays a negative 7, the negative square root of 5 still stayed a negative square root of 5. Everything else maintains the same. Now, one of the things that does happen that is quite nice that we would utilize when we go into division is the fact that when you take a complex number and its conjugate, so I'm just going to take that first pair, and you multiply them together, okay, notice here that that minus 6i plus 6i is going to cancel out. And so now I've got 9 minus 4, and I am going to go ahead and trade that I squared for a negative 1. So it's going to be 9 plus 4, which is 13. The point here is that when you multiply a complex with its conjugate, there are no i's in the answer when this is done, okay? Okay, so now when we get ready to do division, we're not actually going to divide. We're actually going to use multiplication to help us out, but we are going to have to utilize our complex conjugates, okay? Now, when we're talking about division here, the bigger concern that we have is we do not want to have i's in the denominator because they are going to show this division as a fraction type of thing, okay? So the example that we're going to look at here is 5 plus 4i over 4 minus I. Now, the concern here is not the fact that I have an I in the top, okay? We're okay with that because it can wind up coming out as a complex number. The concern here is that we have an I in the denominator. So what we want to do is we want to do this, and the way that's going to be done is you're going to multiply the top and the bottom by the exact same thing, but it's going to be the conjugate of the denominator. Okay, so now we're going to do a little bit of math and then we'll bring it all back together. Okay, so I'm going to start by doing my upper. So that's going to give me 20 plus 5i plus 16i plus 4i squared. So 20. I'm going to combine these two. 21i, 4i squared. We're going to change out that I squared. Negative 1 there. That's going to make 20 plus 21i minus 4. So combining, I've got 16 plus 21i. So that's my top. Okay. So now let's look at doing the denominator part. I realize I just went up over that. So we're going to have 4 minus I, 4 plus I. And again, because we're doing a complex with its conjugate, we shouldn't have any i's left over. So it's going to be 16 plus 4i minus 4i minus I squared. And again, we've got that plus 4 minus 4 on the i's, which is going to cancel out. So I've got 16 minus I squared. Notice here, I just changed the I squared for the -1. That subtractive still there. So it's going to be 16 plus 1, which is going to be 17. Now, this is the bottom. Now, putting this all together, okay, I'm going to put the top back on the top. And the bottom back on the bottom. Now, if you were to put that in, it's probably going to tell you that while your answer is corrected, it's not in the correct format because they're going to want this in A plus BI form, okay? And in order to do that, you're going to have to separate the real, which is going to be the 16 over 17, from the imaginary, it's going to be 21 over 17 I. Now, in this scenario, this will not reduce, okay? However, if you had something like 16 over 12, reduce that, okay? Even if the other part wouldn't reduce any better, make sure that you reduce and clean it up as best you can once it's separated. This is now back in that complex standard form.